In order for us to learn how to write an equation of a line using a point and a rate of change, we should start with a problem in context that we might be more familiar with and maybe come up with a natural solution. So in this particular case, we have a guy named Michael who's working $10 an hour is his rate of pay during his summer job. And if he graphs these amounts, what would his value y be? So we might notice that x is the number of hours worked. So for the first point, that means 6 hours worked. And for the second point, it means he's worked for 8 hours. And then the other one is the amount in the bank account, which means that this is his amount of dollars, $75 at 6 hours, and some unknown amount right here. We've got to figure out what that is. So there's a lot of ways that you might go about solving this, but one of the easiest ways is to simply think about the fact that you're making $10 an hour, and you currently have 75 bucks. So you could take your $75 and you're making $10 per hour and you're working for 2 hours. So 10 times 2 would give you $20, which you would add to the 75 that's already in your bank account, giving you $95. And that's essentially how I could calculate the value of y. Likewise, I could probably make a graphical argument for that. Basically, we could recognize that on the graph, to go from 6 hours over to 8 hours requires us to go up 2 more hours. And we know that our rate of change, or our slope for the line, is $10 per hour, which means we need to go up $20, basically giving us $95. So both of those are really good ways that are going to help us see how to write eventually the equation of a line. So now we might try another problem involving Michael, and basically this time we'd project out further into the future. So basically at 20 hours, how much money does he make? So we might first have to again ask the question graphically, how many more hours is he going to be working? And in this case, I would need to figure out that basically that's 14. I could either do 6 plus 14, or I could recognize that I can get that 14 by doing 20, so his final number of hours, minus 6, which is basically like how many hours he had at the beginning. And that's going to go ahead and give me the 14. So I could again calculate y by saying, I'm starting with $75, and I'm just going to be adding on to $75. I'm making $10 an hour, and I'm working for 14 hours. So that 14 is going in right there as the number of hours. And then we could simply calculate that out. 75 plus 140 is going to give us $215 that Michael would have in his bank account after working 20 hours. All right, so let's go ahead and change our situation. Now let's take a look at this Mr. Stiglitz who's wrapping Christmas presents. It takes him 4 minutes to wrap each present, so that's, notice, a rate of change. And after getting out supplies, so that must have taken some amount of time, he's wrapped 3 presents so far, and it's taken 15 minutes. So let's just say that we look at this and we're trying to kind of figure out what would the coordinates of some point in the future be. So x is some number of presents and y is some number of minutes. You can read that because the minutes is the y-axis and the number of presents is on the x-axis. So if we take a look at this, let's just pick a value for x. Let's go ahead and just start with something that's friendly, like 10 presents, which means that this number right here is 10. And I'm going to go ahead then and write out what calculation I would do. So we've done this enough now. We can basically figure out y. If we know that we have 15 minutes so far, we know that we're going to be adding on to that 15 minutes. So as more time happens, we're going to have more minutes being added on to our 15. So that's what that little dash line is, showing you that basically we're at a height of 15 minutes. And we're going to be adding, and we were told that the rate of change was 4. So 4 minutes times each additional present. But the question is, how many additional presents is that? Well, if I'm at 10 presents right now and I was at 3 before, then I can figure out that difference by doing 10 minus 3. And that number would be 7. So 4 minutes per present times 7 more presents means that I'm adding on 28 additional minutes to the 15 that I already have, which means that I'm going to be at 43 minutes. So therefore, the value of y would be 43 right there, if x was 10. So looking back at that graphically, just to make sense of some of those numbers, this was the 7, so 7 additional presents, and the amount that we went up here was 4, the rate of change, so 4 minutes for each present, times 7 presents. Now let's shift this up just a little bit, because now we could just start to play with some numbers. Let's go ahead and say instead of 10 presents, we now have 25 presents. How many minutes would that take? Well, what would be different in my calculations? Okay, we'll go ahead and go to our point. We'll cross out that 10 and put 25 there. So how many additional presents is it from 3 to 25? Well, I would have to do this calculation. It would be 25 minus 3. That's 22. So my calculation would be the exact same calculation, except instead of having a 7 there, I now have a 22. So 22 additional presents. So instead of 7 right here, that'd be plus 22. And instead of 4 times 7, that'd be 4 times 22. So if I wanted to go ahead and add up those new numbers, then I could compute 4 times 22, which I think is 88 minutes, and then add those two together, which would be 103 minutes. So I can find the new number of y based on the numbers that I have from x. So just to make sure we're seeing this really clearly, notice that the only thing was changing was at first we had 10 minutes, then we had 25 minutes. But the 3 is the same in both calculations. And that's the number that ended up going right here. So maybe another way that I could have written this is y equals 15 minutes to start off with, plus 4 minutes per present. And then I have that number, and I'm always subtracting 3. I did that twice, and if I had more time, I could do that with more numbers of problems, but that number goes right here. So if we think about this, that essentially is the differing value that I keep showing you called x. So in this case, like at the first case, we let x equal 10. So we did 10 minus 3. And in the second case, we did x equals 25. I could just as likely go ahead and do this for any number. Let's say that I wanted to figure it out for, maybe 17 presents. 17 minus 3 would give me 14. 14 more presents from where I am currently at 3 presents. So that should have illustrated a very important point for us, which is this in general. I just gave you a problem in which we knew that the first number of this point was 3, 15. And those numbers showed up in these calculations. For example, that 3 was the number that always showed up here. So I went in the previous example and said it was 10 at first, and so this calculation was 10 minus 3. But I could just as likely have changed 3 presents in 15 minutes and given you some other number of combination, like 5 presents or 8 presents or something. Okay? But in general, in order to figure out how many more additional presents, I would always take this number 10 and then subtract that number 3. And that's really important for us to see this like regularity in our reasoning, because it means that we can begin to write expressions and write things algebraically. So we've got 10 minus 3 was 7 presents in the last example, and then notice that right here, that was our rate of change in the last problem. It was 4 minutes per present, so we were always multiplying by 4, and we are multiplying whatever the number was. So in this case, we had 7, and then that was the 7 that we put here. But then I changed the problem, and so we put 25 here. So instead I did 25 minus 3 and got 22, and then I put that 22 there. But this number right here in front, the rate of change, never ever changed. It was always 4 minutes, because it's how much more additional time you're adding on. So here is the formula that we can come up with. If I want to know this value, the number of minutes, that's this over here, y. If I wanted to know that value, then what I would do is simply take the current amount. So by current amount, I mean the 15 presents that you see here. we were starting at 15 presents, and we always did 15 plus. So that 15 is the coordinate called k in this example. And then I added the rate of change, which was 4. And then that's where I had that from the last slide, the number for x, and then I was subtracting the 3. So that was the value of h, the first point, and this was the value of k. And this right here, the 4, is the rate of change, that's m. And then x and y, that x and that y, those basically just represent the coordinates of some point up here called xy. This is the equation for a line if I know a point on the line, for example, 315. So the point would be called h and k, and the rate of change is m. So I know the point and I know the slope or the rate of change. I can then get the equation for a line.